Now let's see the continuation part of the chemical kinetics, right? Now here they have given some different values of order of reactions based on the rate law. So I told you the rate of the order of the reaction is measured by the experimental data, which can be known by using the mathematical expression from the rate law, right? So now for this reaction you can observe here the decomposition of nitrogen pentoxide. For this reaction the rate is given R equal to K into N2O5 to the power of 1. That means here order of the reaction is 1, right? So by using this stoichiometric coefficient, don't decide the rate of reaction, order of the reaction. Clear? So that will be indicate only the number of moles of N2O5 involved in the balanced chemical reaction. Clear? But order of the reaction is not deciding by using the number of moles of the reactant, right? This is determined by experimentally, that is by using the mathematical expression by rate law. Clear? So therefore in this rate law the sum of the powers that will be here 1 will be there, the order of the reaction for this will be 1. So if you see theoretically you will get the order of the reaction by using this stoichiometric coefficient. You can assume that 2 theoretically, but the experimental order will be the 1. So this kind of order of reactions are called pseudo order reactions. Pseudo order reactions, that means the theoretical order and actual order will be completely different. Those kind of order of the reactions, those kind of order are called pseudo orders. Clear? Now once again, for complex reactions like this here, 5 moles of bromide ion plus BrO3 minus plus 6H plus is gives rise to 3 moles of Br2 plus water. For this reaction the experimental order can be determined by using this rate law. So if you observe as theoretically, like here 5 moles, here it will be 1 mole, here it will be 6 moles, right? So like that if you add we will get nearly 12, but this is the not actual order. Actual order can be determined by based on rate law. So here the bromide ion power will be 1 and here it will be 1 and here it will be 2. So overall order of the reaction is 4. This kind of order of reactions are very rare. Clear? Now let's see one more example here. Hydrogen para is converted into hydrogen ortho. For this rate law R equal to K into H2 para whole to the power of 3 by 2. That means the order of the reaction will be the 3 by 2. So here you can expect most of the reactions which are given are pseudo order reactions. Whatever we are expecting, that order is not getting in the experimental. So therefore this kind of order of reactions are called pseudo order of reactions. Clear? Now similarly here you may see NO2 and CO both were reacted together and forms NO and CO2. So as per the rate law here you can observe that CO to the power of 0, that means the order of this carbon monoxide is 0. Clear? Now here the order of NO2 with respective to NO2 the order will be 2. So the overall order will be 2 plus 0 is equal to 2. So already I told you order may be 0 or order may be fractional, right? Order may be an integer. Clear? Now similarly for this decomposition of ozone, the order of the reaction as per the rate law. What is the uh, order of the reaction with respective to ozone? That will be 2, right? With respective to oxygen that will be minus 1. So therefore overall order will be the 1. Clear? So sometimes negative order also will be there. I already told you it's an integer, 0, fractional, whatever. Clear? Now here the formation of hydrogen chloride, it is completely a 0 order with respective to hydrogen and with respective to chlorine. So both will have 0 order. So therefore the overall order also will be the 0. So you can observe here order may be 0 or order may be fractional, right? Order may be an integer, order may be negative even. Clear? So therefore order we can calculate only based on the rate law. Clear? Now let's see a few more examples of rate of reactions, how to calculate. Okay, now so in a catalytic experiment involving in Haber's process, that is, we know that nitrogen when undergo reaction with hydrogen will give ammonia, right? So for this rate of reaction they have given R equal to, here I'm writing the solution, R equal to 2 into 10 power minus 4 molarity into second inverse, that means mole per liter per second inverse. If there is no side reactions, express the rate of reaction in terms of nitrogen and hydrogen. So for this reaction I am writing rate as minus dN2 by dt is equal to 1 by 3, that also will be negative being a reactant, right? dH2 by dt is equal to 1 by 2 into dNH3 by dt. Clear? This is the rate how we will write for any chemical reaction, right? For this ammonia we have indicated the rate. Now as per the data, rate is given as 2 into 10 power minus 4. So we have to calculate N2 and hydrogen. So obviously N2 will be equal to the 2 into 10 power minus 4, right? And we have to calculate with respect to hydrogen also. So therefore now you can equalize this with the hydrogen. Clear? So now 2 into 10 power minus 4 equal to minus 1 by 3 d of H2 by dt. Now cross multiply, right? You will get the disappearance amount of hydrogen. Clear? So therefore dH2 by dt is equal to 6 into 10 power minus 4. Clear? So here obviously this rate will be equal to the nitrogen, and by using that rate we can also calculate the hydrogen rate. Clear? Now let's see one more numerical. Here I have given the rate of gaseous reaction is given. Here I am writing rate is given for a gaseous reaction as K into A square into B to the power of 3. Now for this reaction, the value of the reaction is suddenly reduced to one half of the initial value. One half of the initial value. Clear? And we need to find out the relation between the old one and original one. Clear? We have to identify the relation between the rate of reaction relative to the original rate. Clear? Now based on that, here we need to understand what they are changing. The volume of the reaction of vessel is suddenly reduced to one half of the initial value. That means we know that here they have given concentrations, right? Rate law is expressed based on concentration. We know the concentration is related with the volume based on this expression, right? Concentration is inversely proportional to volume. That means volume is reduced to half. That means concentration will become get doubled. Clear? So volume is reduced to half, that means concentration will become double. So therefore R equal to K into this concentration of A will become get doubled. So I am writing 2A square into, at the same time here, 2B whole cube. So therefore this is I am assuming as old one. Before changing the volume I am assuming as equation 1, and after changing the volume the concentration will be get affected, which is assumed as equation 2. Clear? Now we have to observe the relation between 1 and 2 after changing and before changing. Clear? So you may assume this is as R1 and this will be R2. Now upon simplifying here 2 square, that means 4, right? 4 into a square, right? And here 2 cube, b coefficient will be 2, 2 cube, that means 2 to the 4, 4 to the 8, b cube. Clear? So this will be the k into 4 into a square into 8 b whole to the power of 3. Now here these two upon get multiplying for simplification purpose, so therefore I will get 32 times 8 for the 32 k into a square into b to the power of 3. So this is what the new rate, right? New rate upon changing the volume, the concentration may get affected like this. Clear? So therefore R2 equal to 32, this k a square b cube we have assumed as R1. That means here R2 is equal to 32 times of R1. Clear? So the reaction rate relative to the original rate will be relative. That means the reaction rate R2 relative, that means ratio to the original rate. Original rate I have assumed as R1, that means R2 by R1 they are asking, that will be the 32, and hence the option will be C. Clear? Now let's see one more numerical here. For the given reaction A plus B is gives rise to C plus D. Clear? I am writing the equation, that is A plus B is gives rise to C plus D. For this reaction concentration of A is doubled without altering the concentration of B. Clear? And at the same time the rate gets doubled. That means for this reaction I am writing the rate law, that is as R equal to K into A into P. I am assuming as this is will be as equation 1. So for this reaction they have changed some factors, that is concentration of B without any altering. Only the concentration of A is doubled. So I am writing here concentration of A is doubled without changing any concentration. At that time the rate get doubled. They have given that the rate get doubled, that means R will become 2R. This is I am assuming as equation 2. Clear? Now if the concentration of B is increased by 9 times without altering the concentration of A, now there is no change in the concentration of A, but there is a change in the concentration of B, that will be increased 9 times. That means 9 times of B concentration increased without any change in the concentration. Therefore the rate will become get a tripled. Therefore the rate will get become tripled. Clear? So this is I am assuming as equation 3. So by changing the concentrations with respective to the reactants, we have to calculate the order of the reaction by comparing with the older rate of reaction. Clear? So now by using this three equations we need to calculate the order of the reaction. So in order to calculate the order of reaction, whatever the rate law I have given, that rate law I am modifying in order to calculate the order of the reaction. A power order whatever it will be there, that will be determined by experimentally, right? So I am assumed as X, and B I have assumed as Y. Clear? Similarly with respective to the change in concentrations, we are also assuming like the same powers as X and Y, which is modified by the changing the concentration with respective to A and with respective to B. Clear? So here by using this mathematical expressions, by using this mathematical equations, what we have assumed, based on that we have to solve the X and Y. Now here divide equation 2 and 1, so B will be get cancelled, so you will get a, right? So now I am solving here equation 2 divided by equation 1. Clear? So what will happen, let's check here. So equation 2 will be 2R equal to K into 2A power X into b power y, right? And divided by equation 1, that will be r. Clear? So divided by equation 1, that will be a power x into b power y. Here concentration of b power y will be get cancelled, r will be get cancelled, k will be get cancelled, and here a power x, here also will be a power x will be get cancelled, and remaining will be the 2 power x. So therefore I am writing 2 is equal to 2 power x. That means upon solving, we know that 2 is nothing but we can also write as 2 power 1. When the bases are same, power also will be the same. Therefore we will get x value as 1. So with respective to a, x will be the 1. Order of a will be the 1. Clear? Now similarly, by solving any two equations, we will get the y value. Now in order to solve the y value, now divide the equation 3 with a 1. So I am writing 3r equal to k into a power x into 9b to the power of y divided by, right, and this will be dividing, this will be dividing, equation 3 will be dividing with equation 1, right? So k into a power x into b power y. So obviously we know that here x equal to 1, right? X equal to 1. So therefore this k a power x, k a power x, and r will be get cancelled, right? And obviously here b power y will be get cancelled. Remaining will be 9 power y, that is equal to 3. That means we can write it is as 3 equal to, we can write it as 3 square whole power y. That means 3 power 2y, right? 3 power 2y. That means 2y is equal to 1. Therefore y equal to 1 by 2. Clear? Now substitute in the equation 1 in order to get overall order. So r equal to k into a power 1 b into b to the power of 1 by 2. This is what rate law as per the experimental data which is modified at the concentration. So now overall order of the reaction is 1 plus 1 by 2, that means 3 by 2. Clear? Now we'll check the option which is the correct answer. Clear? So here the answer will be 3 by 2. Clear everyone? Now here the same model, another numerical we are going to solving. For the reaction 2Hi is gives rise to nothing but hydrogen iodide decomposition reaction at 1000 kelvins they have given. So for the decomposition, whatever the concentration of hydrogen iodide they have taken, with respect to that they have got some rate of reaction. Clear? So based on that data we have to calculate the order of the reaction. Clear? Now let's check based on the data for this decomposition reaction. So therefore in order to calculate the order of the reaction, first order of the reaction we need to first write the rate law. That means here r equal to k into hi to the power of x. I am assuming here to the power of x, where x is the experimentally determined order. So here we have to calculate that x value. Clear? So now as per the data from the equation 1, this is I am assuming as equation 1, and this is I am assuming as equation 2, this is I am assuming as equation 3. So now based on the data, if we substitute, like example, from equation 1 the concentration of hydrogen is iodide is taken as 0.1. With respect to that rate we have got 2.75 into 10 power minus 8. So therefore I am writing rate we have got 2.75 into 10 power minus 8 is equal to k into, when concentration of hi will be the 0.1 to the power of x. Clear? So next, based on the this equation 2 data, I am writing the rate as 11 into 10 power minus 8 is equal to k into 0.2 whole power x. Clear? So now After substituting this data into this rate law, I am assuming this is as equation 4 and this is equation 5. Now in order to get order of the reaction, I am doing this 5 equation divided by 4. Clear? So therefore we will get 11 into 10 power minus 8 divided by 2.75 into 10 power minus 8 equal to k into 0.2 whole power x divided by k into 0.1 whole power x. So k will get cancelled, right? So here 10 power minus 8, 10 power minus 8 get cancelled. Now 11 divided by 12, 2.75, we will get a 4, roughly we will get a 4. So is equal to, and here 0.2 divided by 0.1, nothing but here 2 will be remains, so therefore we will get 2 power x. Clear? So therefore upon solving, we know that 4 we can write it as 2 square, therefore x will become 2. So order of the reaction is 2. Clear? Now here I have given one more question. Try to solve based on the experimental data. You have to write the rate law, and based on that rate law you have to calculate the order of the reaction, and also you calculate the rate constant. Clear? I hope that based on the above numericals which I have explained, based on that you try to solve. Okay now, try to solve. Is there any doubt? You can ask me in the comment box. Okay now, right here you can observe one more question. The rate of the reaction for this rate given as r equal to k into concentration of a into b to the power of 2. When the a is taken in excess, then what is the order of the reaction? So whenever they have mentioned the concentration of any reactant is taken in excess, then the concentration will become constant. There is no change, there is no effect in the rate of reaction. So therefore the concentration of A will be here negligible. Therefore whatever we have remained, that will be the deciding factor for the order of the reaction. Therefore order will be equal to 2. Clear? And the hence option will be the B. Clear? Once again I'm repeating, whenever they have given the data as some any one of the reactant is taken in excess, simply you ignore that, you neglect that, and you consider the remaining concentration of the reactant with respective to that particular order. Clear? So therefore whenever they have given it is in excess, then simply ignore that, remaining will be your order of the reaction as per the rate law. Clear?